All right, welcome back. We are going to dive into something that's a lot more complicated. I know you don't normally think of addition and subtraction as more complicated, but with mathematical operations using scientific notation, it is actually more complicated. You can see that we have to do some adjusting. The steps on here aren't going to quite give it all to you, so I'm going to actually give you some notes like we did on the other ones. I do want to set up this practice problem on my notes. And so I'm just going to say add and subtract. The rules are very, very similar. And we'll kind of go over what the difference between the two is within what we do. So hopefully this explanation will work for both addition and subtraction. We need to kind of tease it out a little bit from each of those. Let's get this problem written down. So we've got 5.0 times 10 to the third. That is in scientific notation. And now we are adding that to another value, 5.0 times 10 to the third. Okay, so what I know is that if I expand these problems, right, I would take, write my 5, and then I would count like from where I am 1, 2, 3, if I fill in my zeros. What I'm actually looking at is 5,000 plus 5,000, which would equal 10,000. But then if I wanted to go back into scientific notation, I would then have to, I could expand it out, and then I could go back into scientific notation by writing it as 1 times 10 to the 1, 2, 3, 4, right? Times 10 to the 4th. All right, so instead of doing that, instead of expanding and then making it smaller, we're going to use the steps for scientific notation, adding and subtracting to scientific notation. But we have to look at a couple of things, okay? One is the distributive property. Oh, let's write it out here. Okay. I just did all of that without showing you what was on my screen. So I just realized, I did this 5.0, 1, 2, 3, expand out to 5,000 plus, so this is the same value, would be 5,000, that would equal 10,000. And then if I wanted, I have to write that in scientific notation. So if I had written it out, I would 1, 2, 3, 4 spaces, and so I'd have 1 times 10 to the 4th. And that's how I could expand it out and do it, but there's a much easier way. Though I do need to kind of set up some knowledge, and that's what I was talking about, this distributive property, which is much like the commutative property, that when I have a value, A times B plus C, that I have to, this means it's multiplied by this value, and that we're multiplying those two values together. So when I write these, A times B plus A times C, that is what we call distributed in. This is where we factored something out. So A has been factored out of this expression, but here it's factored evenly and distributed into this, okay? So this principle we are also going to use when we have to add and subtract with scientific notation. This can be factored out of both of those values, and then we can take and add them and rearrange them, if you will. So if I take this value and plus 5.0, and I have now rearranged this to be factored out, okay? That means now I can do this math, right? So now I know this is 10.0, and I'm multiplying that by 10 to the third. So now I've gone almost back into scientific notation. However, I need to move this decimal one spot, right? I'm going to explain this a little bit differently. I'm going to tell you that if I were to pull a 10 out, if I were to divide or pull a 10 here, right, like divide it out, 1 times 10 to the 1, that would be equal here. And just like with my commutative property, let me use my symbols differently here. Let's say 1 times 10. And remember, 10 to the 1 is still 10 times 10 to the third. And now I'm going to just recombine those two, so that I can rewrite this in actual scientific notation, which would be 1 times 10 to the fourth. Now that I'm putting those together, I have, established that up in our notes further. Okay, I know that many of you have difficulty moving the decimals around, but know that this is it's a pretty easy concept in how to rearrange, or what we call what did it call in the notes? Adjust the answer to be in scientific notation. So what I did here, okay, number 1 in my steps, I made my bases and exponents equal. Well, the bases and the exponents were already equal, so I didn't have to do any adjusting on this particular problem, but I double checked to make sure that they were. Well, I know that the bases are equal because they're all 10, right? We will have to sometimes adjust a number out of scientific notation to do this, and I'll explain it in one of the other problems. Okay, then step number 2, we did combine our coefficients. Now, once we, the basis 10 was already the same, so we didn't have to do any changing to the coefficients, but we have to sometimes change coefficients. And we're going to say by either adding them, if that's what's the value, the operation that is called for, or subtracting. That's according to the problem. Okay. The problem will tell you addition or subtraction. Okay, and then in the third step, we have to go back and readjust the expression to the rules. Oops, sorry about that. The rules of scientific notation. Okay, so these are our rules here. 1, we got to make the bases and the exponents equal by adjusting out of scientific notation if we need to. Let's say if necessary. If those exponents are not equal, then we have to make them equal. And we can't just like move exponents around. We would have to like adjust the whole problem here. So we'll pick a better example moving forward, but we like make the bases and exponents equal by adjusting out of scientific notation if needed. Then we combine our coefficients by either adding or subtracting. And then we readjust the expression to the rules of scientific notation. And that may mean adjusting, or that means that it may mean adjusting the coefficient again. Okay, hopefully these rules will become clear as we kind of walk through this. We didn't have to do anything with this one. Step one was not needed. So when we look at this problem, I will say that it was not needed. It was already established. And then that was our step one up here. Then step two is where I rearranged it, and I talked about the distributive property. A can be distributed into a problem that's set up like this. So once we rearrange, we can definitely rearrange and pull out our 10. Once it's the same, we can pull out our 10 as a factor. You see it's multiplied by this coefficient, multiplied by this coefficient. And so what we have is kind of like a big situation where we'd be factoring something out of. So we can, put this on either side. Know that if I have A here and A here, that I can factor it out. And factoring it out just makes it go back to looking like this. Okay? Then we combine those coefficients. Step two. That equals 10. And then we have to readjust. I mean, yeah, that equals 10, which is greater, it's bigger than one digit, right, in the ones place to the left of that decimal. So we have to make our adjustment here. And I went ahead and made this adjustment kind of using a trick and writing this in scientific notation, just this part, to get a 10, and then putting those two 10s together. And that's my step 3. Okay, so this can mean adjusting the coefficient again. Here's the trick. Write the new coefficient in scientific notation. Then combine the new and old, it's not old, but original bases by, there we go, by adding the exponents. Okay, it's pretty straightforward, but this little trick will do you some good. Okay, now I'm going to take a picture of these notes, so I'm not going to spend a bunch of time on it. These notes will be added in PDF form to the assignment that you guys are working on this. So let's take a look at another sample problem that fits the needs of us getting our steps figured out. Okay, so we are going to do this problem. I'm going to write it down. While you got it there in front of you, you go ahead and write it down on your notes. So I'm having to move to a new page, so you're going to see that I've got 1.0 times 10 to the 4th. Okay, and that is going to be added to 5.0 times 10 to the 2nd. All right, so what I really have here now, I have two bases that are not equal. So like I said before, and we'll kind of go back to these notes, that step 1 is I have to make the bases of the exponents equal by adjusting these out of scientific notation if needed. So I'm going to adjust in my scientific notation, and I can kind of use this trick. This is the helpful trick, okay? So I will walk you through that, and hopefully it'll stick with you. So we'll deal with each of these individually. First, it will typically be easier. Well, it doesn't matter, really. But we can, I'm going to start with this one here, okay? I'm going to take and use this problem right here. So 1.0 times 10, and I'm going to take this base and I'm going to make it so one part of it is equal to this one here, 10 to the 2. So if I have 10 to the 4th, that means now I have 10 to the 2, right? And now I am going to combine these guys together. So let me rewrite this so it all stays equal. It's the same problem. Okay. But now I've got 1, and I need to multiply that by 10 and 10 again. Or I need to move my decimal over 2 places, right? So again, 1, 2, I can put that there. So 1 times 10 squared, or 10 to the 2, should be 100. I hope that makes sense to you. Well, I guess I could show you the process here. Well, boom, boom, that's my 100. Okay, so that's how I would rewrite this whole number. So let me use my space. 100 times 10 to the 2, right? That's that whole thing there. Now it's been adjusted. I use my little trick of rewriting this or pulling this apart, right? It's a very similar trick. And just playing with those exponents. See, 10 to the 4th is 10 to the 2nd and 10 to the 2nd. And since I needed to match 10 to the 2nd over here, that was an easy way for me to adjust it. All right. Okay, so now what I have, I've got the base that is the same. I would like to rearrange this so that I can factor it out, right? I know that this was step 1, right? I had to rewrite this guy so that my bases now matched. Okay. Now I can add my coefficients together. I'm gonna, there's a skipped step in here, and I'm gonna factor out this 10 to the 2 and show you why it works to add the coefficients together. All right. That right there is the same as writing that, and I can just factor it, right? And I can rewrite it as 100 plus 5. Those ones will get combined times 10 to the 2nd. And now I've got it set up for being written in scientific notation. So step 2, I'm going to combine my coefficients. 100 plus 5 times 10 to the 2nd. All right. Am I in scientific notation? No, I am not. So let me take this value right here, my trick, right, is to rewrite that in scientific notation. Just the coefficient. This gets rewritten, and we also then include this base 10. But 105, remember, if I'm doing my steps, right, I have an unsaid decimal here, and I go 1, 2, it's now going to move. I have to be 1.05 times 10 to the 2nd. That would be rewriting this whole thing in scientific notation. So that right here would replace this number. Now this coefficient is written in scientific notation. I also have this one. That doesn't go away. So it's definitely part of the problem still. And now instead of combining these two words together, now I'm going to combine my bases. So my number is 1.05 times 10 to the 4th. One number to the left of the decimal, and I have multiplied that by a base 10 to some exponent. And this, my friends, is in scientific notation. So my answer is multi-stepped, and I have to reuse some rewriting. Got to get used to the multiplication and the tens. And if you are still stuck, you're still lost, it is really important that you understand the basics of scientific notation and that what we are doing is multiplying and dividing by tens. Okay, so let's try one more sample problem. Check my answer. My answer is good. I'm going to actually go in for subtraction. The problem is very much the same. All right. So in this problem, here we have our addition. So this was an addition sample. And I'm going to have a subtraction sample. Alrighty. Okay. And 9.5 times 10. I guess I should write on the lines. Okay. 9.5 times 10 to the 99th. Oh, this one's an easy sample because our bases are the same, huh? And that would be, we're going to subtract from that 4.4 times 10 to the 99th. All right, we'll do this one and then we'll do a more complicated one. Okay, so we don't have to do step one. There doesn't have to be any adjusting. We can just factor out the 10 to the 99th. So we're going to go 9.5. There is my operation, and 4.4, and I know that that is being multiplied by the 10 to the 99th on both of those, so I can factor that out. I can also write it as I would traditional scientific notation. Okay, just like that. Either one of these is true for scientific notation. We're just more traditionally, we see it this way. All right, so subtraction-wise, I've got 5.1 on my coefficient times 10 to the 99th, right? Give myself a space here. Use my spaces. All right, I'm in scientific notation. I don't need to make any adjustments. That one is way too easy. Okay, so there's my subtraction sample. That's like super duper straightforward and easy. And then I'm going to do another one that is less easy. We're going to do this 8.8. So I'm going to use the same paper, 8.8 times 10 to the 68th. I'm going to write it down. You go ahead and write it down on your paper. Take away 3.5 times 10 to the 65th. All right. All right, so now I'm going to mess with this one, okay? Just because it's easier for me just to deal with this guy here. So in rewriting, 8.8 times 10 to the, well, what I gotta have, like 10 to the 3rd, if I split these apart, and then 10 to the 65th, right? Okay, that leaves me to combine those two and make my adjustment. Okay, since this is a 65, it's just easier for me to kind of manipulate that there. So this is my step one, okay? I am rearranging, right? And now if I want to solve this out to expanded form, it's going to be 1, 2, 3 places. And I'll kind of ghost those. And I can go ahead and rewrite this as 8,800 Okay, so that's the equivalent right there, times 10 to the 65th. And even though this isn't in scientific notation, it's going to get there. Remember that my adjustment, I'm going out of scientific notation first. Okay, now I can factor this out, right? These two are the same, and they're both being multiplied. So I'm going to pull those both out of that operation there, and that would be rewritten as 8,800 minus 3.5 times 10 to the 65th. Okay, that gets rewritten step by step as I'm pulling this math out. Now I'm going to just deal with what's in the parentheses. Okay, 8,800 minus 3.5, which I'm going to would be 8,796.5, I believe. I'm going to do a quick check on that, make sure my math is correct. My COVID brain is not super awesome lately. Yeah, that is correct. You can see I got my answer there. Okay, but that is not in scientific notation. That just took me here, right? And so now I need to make this adjustment. Now I'm going to take this number right here and write it in scientific notation. So I would move 1, 2, 3 places. So it would be 8.7965 times 10 to the third. And don't forget, got to keep this in here, times 10 to the 65th. And this gives me a new coefficient that's written properly. Okay, this is how I would, I don't know like how to denote that really, but what I want you to see is that I'm just writing this coefficient in scientific notation and including the whole big thing. You can't just drop this off, right? But now I can combine these bases and I get 8.7965 times 10 to the 68th. Check my answer. Boom. Got it. All right. I know that these steps are difficult. You have to go slow and you might have to really follow each step. It's best not to skip steps. It's best to remember that I can move some things around with something called the commutative property. Remember that I can take these apart and use base 10s. 10 to the third and 10 to the 65th would equal 10 to the 68th. And that's why I can do those tricks on subtraction and addition. Hopefully that helps you. And you can give it your best shot.